So starting our third unit, we're going to get into quadratics mostly, but really a quadratic is a form of a polynomial. So today we're just going to remind ourselves how we add, subtract, and multiply polynomials. So what does it mean to be a polynomial? A poly is many, friends. So many terms is what we would say. This first little iteration here, this is really kind of our fanciest way of getting a general polynomial. We always start with the highest exponent term. So n, for example, could be 4, could be 10, could be 2, right? And then we always go in descending order of powers. So you'll notice the next term would be the next lowest, n minus 1. So if n was the fourth power, x to the fourth, then x to the n minus 1 would be x to the third, and so on and so forth. So we always write them in descending order of powers. So I've put up just 3 examples up here. Notice this is like x squared, so then this would be x to the first. We don't have to show the exponent there. This is really like x to the 0 power, right? Anything to the 0 power is 1, so it's kind of just gone. We would say there are 1, 2, 3 terms here. And so we would call this thing specifically, not necessarily a polynomial, but a trinomial, to represent tri for 3 terms. In our next example, we really only have 1 term. So this also kind of has a unique term for it. We would say this is a monomial. And one word that you're going to hear a lot throughout this entire third unit is how to describe 2 terms put together. When we have 2 terms, again, this is like x to the first, this is kind of like x to the 0. So they really are in that descending order of their powers. We don't necessarily write it that way because it looks more complicated, but it is there. And if we have 2 terms, we call this a binomial. And we will work with binomials quite a bit during this unit. So these are just some special case names that we work with. To work through our next couple of examples, we're really just adding and subtracting. And so the biggest thing to remember here with these examples, I'm just going to give ourselves plenty of room here. The biggest thing with these examples, I'll put them in a certain, this guy we'll start with first, is that we can only add and subtract like terms. So what do we mean by like terms? Not only do they have to have the same variable, the terms, like x's with x's, y's with y's, but they also has to have, so and has to have the same exponent value on the variable. So we can't add x's with x squareds. We can only put x's with x's. Likewise, we can only put x squareds with other x squareds. So when we're doing this, it's really nice if you've got colors to kind of organize them, but you could also achieve this with certain types of underlining. So I'll use some certain colors. So I look at this first example here, this guy, and I say, oh, there's a y squared term. And then I start scanning through for other y squared terms. Oh, I see no other y squared terms. So then I would get either a different color or you'd underline the next type of term, right, because it's different, a different way. So here's a y to the fourth. You might use a zigzag for this one. And then I kind of scan through for other y to the fourths. There's one. So I can underline those the same way. Those 2 can be put together because they're like terms. Keeping down this path, I've got, oh, there's a, so maybe on this one, it's not very clear. I'll use like a swirl, and I look for other single constant values. Nope, I don't see any other single numbers. Switching colors again, I see a y term here, so maybe you would use like a little bubble underneath that guy. I look for other y terms. Oh, there's one. And then finally, we've got one lingering, I'll have to grab a different color here, one lingering y cubed term. So kind of putting these all together, there is a nice way to do this and a not so nice way to do this, friends. We still want to start with the highest term. So I'm going to go back and just do this with our y to the fourth. So start with highest exponent and then work our way down. So if we have the 2 green, essentially, terms are like terms. So a negative 6y to the fourth plus 5y to the fourth, that leaves us with a negative 1y to the fourth. Check, check. Next, going in descending order, we would go to our y cubed. There's only one of those, so we can just check that one off and leave it as is, minus 6y cubed. Then working our way down to the y squared. Again, there's only one, that's the one here identified in red. So a plus 3y squared. Down to our single y's, we would use a negative 6y in purple right here, and a positive 4y over here, leaving us together when we combine them, and a negative 2y, and then finally leaving our number term at the very end. So we would put a big old plus 5 here. So now we have written this polynomial in descending order of the exponent values. My friends, I believe that all of you could do it, but there is kind of a right way and a nice way to write these. This is it. When you come down to the second example for subtraction, there is a big thing. Caution with subtraction. And the big caution here is if you are subtracting more than one term, friends, we have to distribute the negative. So before we even start identifying the like terms, we would go ahead and say, okay, minus 9b squared is a negative 9b cubed, or b squared, b cubed, minus, this is a 4b to the fourth, so that becomes a negative 4b to the fourth when we distribute it, basically just switching all the signs in that second parenthesis, and then minus a negative 7 becomes plus 7 here. And everything in that first parenthesis stays put. So doing what we did up above, I'll try to use the same color combo, although it doesn't really matter. It looks like we have b to the fourth is the highest power. So that guy will underline this way and this way. If we put those together, we get ourselves a negative 2b to the fourth. Next one down, we do have b cubed. If I follow the way we did this up above, so the b cubed, and then the other b cubed over here, we can combine them because they are like terms. So a negative 6b cubed and a negative 9b cubed, we should end up with a negative 15b cubed. Notice we don't have any b squared terms, so we can kind of skip that one. We do have a single b term here. So that one does not look like it has any other like terms with it. So we would just simply write a plus 5b. And then finally at the very end, we could go ahead and do our single number at the very end plus 7. So the moral of the story is very similar processes from the top example to the bottom, but with subtraction, we almost always are going to have to do our distributing the negative first. Okay, the majority of this lesson is going to be kind of refreshing our multiplying skills, right? So to multiply polynomials, each term in the first polynomial has to multiply each term in the second. So friends, really quick refresher on FOIL. We'll do this slowly about one time, and then I kind of expect you to have it. So the FOIL, this is our first, outside, inside, and then our last terms. So as a quick little reminder, first terms means let's multiply the first terms together in each binomial. So a 2x times 5x. Now when we're multiplying, we don't need like terms. So 2x times 5x, that gives us a 10x squared. Check. Outside terms refers to the outermost terms of the binomial, right? So the furthest one's out here. So what we're really doing is we're really taking that 2x and distributing it through to both terms in the second binomial. By doing this FOIL, that's kind of just a quick way to remember this. So that 2x multiplied the 5x, that gave us the 10x squared. Now we got to do the second term, so the outside. So 2x times 6 is a plus 12x. Check off the O. Next, we're going to look at doing the inside terms. So that's the innermost terms. So again, thinking about what we're really achieving with FOIL. Now we're taking the second term of this binomial, of this first one, and distributing it through to this last parenthesis set here. So taking the innermost terms here, a negative 5 times a 5x is a negative 25x. And then finally, what we mean by L, so I is done. What we mean by L is that the last term in each binomial. So a negative 5 times a positive 6 is a negative 30. Be very careful here not to add or subtract those two values. That's a very common mistake. And then it doesn't always happen, but what frequently happens is we end up with the ability to combine our inside and outside terms, as we do here. 12x minus 25x is a negative 13x. And this cannot be combined with a single number, the minus 30 at the end, and it cannot be combined with the x squared at the beginning. So this is our result on this one. Okay, so how does this further complicate? How would we multiply a binomial times a trinomial, right? There's three terms in the second one. So think about what we're really trying to do here. We take the first term in the first parenthesis, and we have to distribute it through to all three terms in that second parenthesis. So let's do this one step at a time. Y times negative 2y squared is negative 2y cubed. Y times our second term over here, so y times positive 3y is a positive 3y squared. Y times negative 6 is a negative 6y. Okay, so this is where we can make better choices and not better choices. I'm going to try to help you make a better choice on making this nice and clean. So now the next thing we have to do is take the second term in that first polynomial, the first binomial, and we have to distribute through to all three terms over here. So I'm going to strategically do this and line up the like terms. So for example, the negative 2 times negative 2y squared, that's a positive 4y squared. I'm going to put that in the y squared column. So everything is going to add together that goes together. Then we take this negative 2 times a positive 3y, and that becomes a negative 6y. So I'm going to put that in the y column with the other like term. And then this negative 2 times negative 6 becomes a positive 12. There is no single number term, so I'm going to make its own column here. And what we've really done here is just created a little addition problem of like terms. So we end up with a negative 2y cubed plus 7y squared minus 12y plus 12. Okay, so moving along, a few more. Let's do this next one. How would we do three different binomials put together? Well, friends, just like we would start the first two, right? So let's start by multiplying our first two. We could just FOIL this guy together, and then we will multiply the next one. So start with just our first one here. I'm going to erase this guy. That's really, we're putting this on hold for a moment. Okay, so let's multiply first terms together. X times 2x is a 2x squared. Outside terms now, so x times a positive 1, that would be a positive 1x, or just x. Inside terms, now we're moving toward the inside terms. Negative 4 times 2x is a negative 8x. And then finally, last terms, so negative 4 times a positive 1. Again, don't fall into the trap of adding or combining those by addition. They are multiplied. So negative 4 times a positive 1 is a negative 4. And again, as we saw earlier, we can combine the inside and outside. So this would be a negative 7x in the middle terms. We still have the minus 4, and we still have the 2x squared out front. This now takes the place of the two binomials up top are replaced with this one trinomial. But we still have to multiply that by the 3x minus 2. So kind of using a combination of tactics here. Now we've got to take every term in our first trinomial, so this 2x squared, has to multiply by every term over here. So we're essentially just distributing step by step here. So what's 2x squared times 3x? That would be a 6x cubed. 6x cubed. Then we take our 2x squared times our second term over here. So 2x squared times negative 2 gives us a negative 4x squared. Okay, so kind of color coding this just so you can kind of see and follow more clearly. Now we're going to take the second term in that first parenthesis set and distribute it through everything in the second one. So this negative 7x times 3x, that's a negative 21x squared. Again, I'm lining up my x squareds together. This negative 7x times a negative 2 would be a positive 14x. Going to create a new x column because I don't have one. And then finally, we've got to take this negative 4, still in that first parenthesis set, and distribute it through to both terms over here. So this would be a negative 12x if we take negative 4 times positive 3x. And then negative 4 times this negative 2 here would be a positive 8. And now, because we have kind of strategically lined up our like terms, adding should be a breeze, or combining here should be a breeze. So this gives us just our 6x cubed. Minus 25x squared. Looks like we've got a plus 2x and then a plus 8 here. Okay, you might be thinking, hey, I got this. I don't need to watch the rest of this. But my friends, I put this last example on here for a reason. This is one where I will catch errors through the end of this school year on problems like this. First of all, first and foremost, I have to stop. This is our first thought, that this is equal to x squared plus 1. It is not. That is not the case. When you are squaring something, so let's just kind of come up here. When I say 3 squared, I'm really saying take 3 and multiply it by itself 2 times. So by this notion, what that's really saying, by x plus 1 squared, I'm really saying take x plus 1 and multiply it by x plus 1. This is a FOIL situation. We cannot distribute an exponent across addition and subtraction. So let's go ahead and set this up accordingly. This is x plus 1 times x plus 1. This second one is also a FOIL situation. 2x minus 7 times 2x minus 7. These things are still connected by this subtraction in the middle. So just kind of bringing this down. Thinking about the order of operations, we are going to multiply first. So that's 2 different multiplications. Multiplying here means FOILing. And then we're going to distribute the negative in the center to combine them by subtraction. So let's one step at a time this day. Let's FOIL the red first. X times x is x squared. Outside terms would give us a plus 1x. Inside terms would give us another plus 1x. 1 times 1 is not 2, friends. It is still 1. So then combining our inside and outside, this becomes x squared plus 2x plus 1. Let's now do the green. So 2x times 2x, that's 4x squared. 2x times negative 7 is a negative 14x. Inside terms, negative 7 times 2x is another negative 14x. And then finally, our last terms, negative 7 times negative 7 is a positive 49. Again, we see the same, combining our inside and outside terms. This becomes 4x squared minus 28x plus 49. Friends, I have to keep parentheses around that second result. The reason being, because I am subtracting all of those terms. If we don't keep the parentheses in there, we don't see that distributing the negative. So this really is a negative 4x squared plus 28x minus 49. When we go to combine with these first terms here, x squared plus 2x plus 1. And then this becomes a problem much like we did in our first few examples. We underline our x squareds can be combined with other x squareds. Our x's can be combined with other x's. And finally, our numbers can be combined with other numbers. So kind of putting this all together, we have a single x squared minus 4x squared is a negative 3x squared. We have a positive 2x and a positive 28x. That's a positive 30x. And then we have a positive 1 and a negative 49, so that leaves us with a negative 48.